Let's start with our lecture. Issue to be tested in Michelson-Morley experiment. So, what was the issue which was to be tested in Michelson-Morley experiment? So, it wanted to test that is there a special frame of reference called ether. I have already told you regarding ether in the previous lecture. Okay, so ether was such a frame which was considered to be at absolute rest. Okay, ether was such a frame which was considered to be at absolute rest, and when we measured the quantities, the assumption of the physics at that time, the physics that existed during those days, it assumed that whatever values we measure with respect to ether, those are absolute values, those are true values, and whatever values we measure from frames other than ether, so ether was considered to be at absolute rest. So we whatever values we measure other than ether frame, those values are not true values. Those values are indeed modified values. Okay. So we had the issue which needs to be tested in Michelson-Morley experiment is there a special frame of reference called as ether? Does such a frame even exist? Does ether even exist? That is what we had to look at. Okay, that is what we had to think about. Okay, and this ether was a frame in which the speed of light is given in terms of the following equation. Okay, so this ether was such a frame in which this equation holds good. C equal to 1 upon square root of epsilon naught mu naught. Okay, what is this equation? C equal to 1 upon square root of epsilon naught mu naught. This equation holds in ether. It was assumed during those days in the physics of 1890s. It was assumed that this particular C value is valid only in ether frame of reference, and with frame of reference the velocity of light will change. Okay, so in different frame the velocity of light will be different. But if it is an inertial frame, then the velocity of light will be different in that inertial frame. Okay, so involving this, these are what? Epsilon naught and mu naught. Epsilon naught and mu naught are fundamental constants. You already know this very well. Okay, this epsilon naught and mu naught, what are they? They are fundamental constants. So issue to be tested was that is there any special frame of reference called as ether in which the speed of light is given in term of the following equation, which involves the following fundamental constants, and is there anything called as absolute rest? Is there anything called as absolute rest? This is also the fact which needs to be tested. Okay. Now, another question was that is it that in all other inertial frames other than ether, the speed of light is different? Okay. What do you mean by an inertial frame? A frame which is either at rest, a frame which is either at rest or moving with uniform velocity. Okay. A frame which is either at rest or moving with uniform velocity, that is called as a inertial frame. Okay, uniform velocity or rest. So what the ether hypothesis said is that the rest frame was ether frame. Okay, the frame which was at rest was ether frame, and these two frames are inertial frames. These two frames are inertial frames. Okay, but but if we want to measure the velocity of light correctly, then the frame at rest must be chosen, and the frame at rest is the ether frame. Okay, this was the assumption of the physics during those days. Okay, this was the assumption. Now, is it that in all other inertial frames which are moving with uniform velocities and which are not at rest, the inertial frames which are not at rest and are moving with with constant velocity? Okay, so is it that in all other inertial frames which are moving with constant velocity, the speed of light is different? Okay, the speed or velocity of light is different in those inertial frames or not? Okay, and would be given by a standard velocity addition relative velocity formula. Would be given by a standard velocity addition and relative velocity formula. What does it mean? It simply means that vectorial addition of speed of velocity, not speed. Vectorial addition of speed. You already know the vector law of triangular vectorial law of addition. Okay, you already know that vector addition. Vector A plus vector B gives vector C. Okay, triangular law of vector addition you already have learnt in the lower classes. Okay, I am not going in that. So it was assumed during those days that in inertial frames other than ether, when you try to measure the velocity, it will be found to be the velocity of light could be found by standard velocity addition or relative velocity formula or vectorial law of triangle addition. Okay, triangle law of vector addition. By that method we can find out the velocity of light in different inertial frames other than ether and inertial frames which are moving with uniform velocity. Okay, so that was the assumption during those days. But it was a wrong assumption. It will be proved later when Michelson-Morley experiment will be done. After that, Einstein's special theory of relativity postulates will come into picture. And according to those, Einstein's special theory of relativity postulates, speed of light c is an absolute constant. We now know speed of light or velocity of light c is an absolute constant. It does not depend on the state of motion of the frame. Okay, this is what we know now, but in those days we did not know this. In those days we did not know this particular fact. Okay, so in those days the ether hypothesis said that when you measure the speed of light, when you try to measure it in inertial frame moving with constant velocity, it will be given by triangular law of vector addition. Okay, or standard velocity addition formula or relative velocity formula. So see, they are applying relative velocity formula on light as well, which was proved to be wrong later on, but during ether hypothesis days it was done like that. Okay, they did not know that speed of light c is as absolute constant. They did not know this particular fact. Okay, let us learn about the implication of the ether hypothesis. Okay, so this forms the base of the Michelson-Morley experiment. This implication of ether hypothesis is the thing which forms the base of Michelson-Morley experiment. So let us assume according to the ether hypothesis. Okay, according to this hypothesis, assume an object O is there, suppose, and a beam of light is there in the ether medium. So the thing is that this object O, this yellow object O, is moving with a constant velocity v. Okay, constant velocity v to the right hand side. Okay, this is the constant velocity v of this object O. Okay, and this is relative to ether. This v is relative to ether. This c and this c is also relative to ether. This c is also relative to ether. Okay, now what is c? C is the velocity of light relative to ether. Okay, so this is also relative to ether and this is also relative to ether. Now both the shown velocities are relative to ether. So this is velocity of light, the velocity of light beam. Okay, this is object, and this object has a velocity v in the rightward direction, uniform velocity v in the rightward direction. Okay, and both these shown velocities are relative to ether, and as the velocity of light is being measured with respect to ether, so its magnitude will be equal to 1 upon square root of epsilon naught mu naught. This already we learned some moments ago. Okay, so magnitude of velocity c will be equal to 1 upon square root of epsilon naught mu naught according to ether hypothesis. Now the velocity of light in the object frame O would then be given by c minus v. Okay, so the velocity of light in the object frame, if we want to measure the velocity of light in object frame, this is in ether frame, this is also in ether frame. But if we want to measure velocity of light c in ether frame, what will we do? So the velocity of light in the object frame, if you want to find out velocity of light in object frame, then what will happen? It will be given by c minus v. Okay, it will be given by c vector minus v vector. Why? Because with respect to the object will be at rest. Okay, so by the formula which you have learned in the lower classes, vector c minus vector v will be the velocity of light with respect to object O. Okay, so velocity of light in the object frame O would then be given by c vector minus v vector. Let us assume it is equal to Vm vector. It is equal to Vm vector, let us suppose. Now this Vm vector is the velocity of light as measured in object frame O. Okay. So this Vm is the velocity of this light in object frame O. This is O. This is O. Okay. This is O, which has been used to denote this object. This object has been denoted by the symbol O. Okay. So let us assume that the velocity of light with respect to the object is velocity of light as measured in the object frame O is Vm, let us suppose, and Vm vector will be equal to c vector minus v vector. This is very much clear. Okay. Now you can have a look at the triangle law of addition. So from here what can we say? From here one can clearly say that Vm plus v will be equal to vector c, right? From here one can clearly say this. So by applying the triangle law of addition, Vm plus v will be equal to c. Okay, and Vm plus v will be equal to C. This is from the triangle law of vector addition, which you have learned in the lower classes. These two figures are from the triangle law of vector addition learned in the 11th and 12th standard. Okay. So this is how the things will look like. Okay. So this is the thing. This is the figure which we have drawn. This is the figure which we have drawn with our common sense. So Vm vector is equal to C vector minus V vector is the measured velocity of light in the object frame. I already told to you in the previous slide. Okay, measured velocity of the object of the light in object frame, and its magnitude depends on the direction of C vector, and the magnitude of this Vm vector depends on what? Magnitude of this Vm vector will depend on the direction of C vector. We have assumed that this is constant. Okay, what we have assumed is that over here the assumption is that this particular vector V vector, okay, its magnitude is constant. We have assumed this. Its magnitude is constant and its direction is also fixed. Okay, its direction is also fixed. Its direction is also fixed and its magnitude is also constant. That is what we have assumed for this V vector. So the thing is that V vector, what is V vector, by the way? The velocity of the object. So the velocity of the object is constant and its direction, magnitude of velocity of the object is constant and its direction is also, the direction of velocity is also fixed. Okay. So it is saying is that the magnitude of this Vm, okay, will depend on the direction of this C. Okay, if C is in this direction, if C vector is in this direction, then Vm will be different, and if C is in this direction, then Vm will be different. Okay, if C is in this direction, Vm will be different. If C is in this direction, Vm will be different. If C is in third direction, then Vm will be again different. Okay, so this is the thing. So the measured velocity of light with respect to object, that is measured velocity of light in object frame, its magnitude will depend on the direction of C vector. Its magnitude will depend on the direction of C vector, even if V vector has a constant magnitude and a fixed direction. That is what is the meaning. Okay. Now from here we can clearly write this particular thing. From this expression we can certainly write Vm vector plus V vector is equal to C vector. Okay, we can certainly write Vm vector plus V vector is equal to C vector. We can certainly write this particular thing from here. Okay. If the ether hypothesis, if it is correct, then what will happen? Then in O frame, which is the O frame? Have a look over here. Then in O frame, what is O frame? O frame means objects frame. O frame means objects frame. Okay. So then in O frame, one should measure different values of velocities of light. Okay. So we should measure different values of velocities of light with respect to O. Okay. When the direction of light makes different angles with the direction of motion of object in ether. Okay. So when the direction of motion of light makes different angles, although the velocity v, which is the velocity of the object, it is constant in magnitude and fixed in direction. That is, the velocity is constant. Okay, velocity is fixed both in direction and magnitude. But if we change the direction of motion of light, what is happening? The velocity of light with respect to object, is changing. Okay. So one should measure different values of velocities of light in this O frame when the direction of light makes different angles with the direction of motion of object in ether. Okay. The measured velocities should be consistent with the velocity addition formula. This also we have already learned just now. Okay, the measured velocities should be consistent with the velocity addition formula. So the triangle law of vector addition, they will follow. This is what is the meaning of this statement, that the measured velocity should be consistent with the velocity addition formula. Ignore all the motion of Earth other than its orbital velocity. Now Earth has very different kinds of motions. It rotates on its own axis also. So Earth, suppose this is Earth. Let us assume this is Earth. Then what will happen? The Earth also rotates on its own axis like this. Okay, and it also goes around the sun in elliptical axis. Okay, and also spins on its own axis, and also goes around the sun in an elliptical axis. Okay, elliptical orbit. Now you will only consider the orbital motion of the earth. You will neglect the rotation of earth. Okay, on its own axis, rotation, you will neglect. Okay, you are going to neglect this, and you will only consider the orbital motion. What does it mean by orbital motion? Orbital motion is the motion around sun, motion of earth around sun. You will only consider that. And we are considering the velocity to be in a straight line, because during our Michelson-Morley experiment, the distance which the earth will cover around the sun, that will be approximately straight line. Okay, the velocity of earth for a short duration will be approximately straight line, because this elliptical path is very large. This elliptical path around the sun, elliptical path of the earth around the sun is very large. That's why during Michelson-Morley experiment, the velocity can be taken to be in a straight line, because the ellipse is very large. So during the experiment, the earth will only cover a little bit of the ellipse distance, a little bit of the elliptical curve. And if an ellipse, if it is very slight ellipse, then it can be considered to be a straight line. If it is very slight ellipse, then it can be considered to be a straight line. Okay, so that's why let its velocity, let us assume this is earth, let us assume this is what, this is earth. Okay, and we have ignored all the motion of earth other than its orbital velocity. We have ignored all the other type of motions. Okay, let its velocity at a given instant be v vector with respect to ether. So the earth is dragging in ether. Ether is filled everywhere. Ether is filled everywhere. Ether is stationary. It is filled everywhere. And the earth is moving. It is dragging in ether. The earth is being dragged in ether. Okay. On earth, on earth, this is the planet earth, and this is its orbital velocity v in rightward direction. Okay, that is its motion around the sun. Okay, so on earth, if we send two light signals, so this is earth, if we send one light signal like this and another light signal like this, if we send like this two perpendicular light signals. Okay, so on earth, if we send two light signals, one along its velocity direction, that is this green one which is along the velocity direction, and another perpendicular to it in the earth's frame, and another perpendicular, this light signal is perpendicular to velocity of earth, and this light signal is parallel to velocity of earth. Okay, these two should travel with different velocities when measured on earth. So when we measure on earth, as earth is a moving object, although it is inertial frame, although earth is an inertial frame, but it is an inertial frame moving with constant velocity. It is an inertial frame moving with constant velocity. Okay, so the speed of light according to ether hypothesis will change. It will not be the real velocity. The velocity of light as measured from earth will not be real velocity. It will be modified velocity, because earth itself is moving. Okay, and the velocity of light is constant, but where velocity of light is constant only in ether according to ether hypothesis. If we measure it on earth, it will be modified, because earth is an inertial frame moving with a constant orbital velocity around the sun. Okay, and although the path is elliptical, we have taken it to be a straight line, because during Michelson-Morley experiment, the earth will travel only a very small portion of the ellipse. Okay, and a very small portion of the ellipse can be considered to be a straight line. That's why this velocity has been taken to be constant. That's why, because earth is not moving in a curved path for such a short time. Okay, it is approximately a straight line for such a short time. Okay, so this is the thing. Let us have a look at the figure. Okay, so this is planet earth. This white is planet earth, which is moving with a velocity v vector in the rightward direction like this. Okay, now we have sent two light beams. One is perpendicular to the velocity of earth and another is parallel to the velocity of earth. Okay, so this light beam which has been sent perpendicular to the velocity of the earth, okay, as the velocity of light in ether is constant, so this velocity v perpendicular will be given by c vector minus v vector over here. So I am representing this with v perpendicular, and similarly the result, if this is the beam of light which has been sent parallel to the velocity of earth, okay, emitted parallel to the velocity of earth, orbital velocity of earth, parallel to orbital velocity of earth, if this is emitted, which is v parallel vector, then certainly it will be equal to c vector minus v vector once again, and this is also following the vector law of addition. Okay, only the thing is that over here triangle is not being formed, instead of triangle the line is being formed. So this is a special case where the angle between this green vector and blue vector, the angle is 0. Okay, but the law is the same, the law with law in these and law in these, in both of these the law will be the same, but the measurement of magnitude will be different. Measurement of green vector's magnitude, it will be measured in a different way. Okay, and what is this green vector? It is the velocity of light with respect to earth, velocity of light beam in perpendicular direction with respect to earth, velocity of light beam in parallel direction with respect to earth. Okay, so this is the thing. This signal has been sent in perpendicular direction, this signal has been sent in parallel direction. C vector minus V vector is the common formula. Okay, C vector minus V vector is the common formula for finding the green vector. For finding this green vector and green vector, that is the velocity of light with respect to earth, that is the velocity of light with respect to earth, the common formula is C vector minus V vector, that is the yellow vector minus blue vector, the yellow vector minus blue vector, that is the formula. Okay, but the thing is that the magnitude will come out to be different in every case. Okay, the magnitude will come out to be different. Over here a right angle triangle is being formed. Okay, and over here a straight line is being formed. So the magnitude will be measured differently here, and the magnitude will be measured differently here, because over here straight line is being formed and over here right angle triangle is being formed. So let us look at it.